Hello and welcome back to Metlynx. In our previous presentation, we introduced Metlynx as a web application for scientific computing, and we gave a demo of Metlynx for Spreadsheets, which is a cloud service that integrates MATLAB language scripts and Google Spreadsheets. We also showed some simple curve-fitting type examples to demonstrate that integration. This time we'll give a much more comprehensive example to illustrate some of the advanced capabilities of Metlynx for Spreadsheets. Today we'll look at Metlynx for Spreadsheets as applied to statistical analysis of digital communication systems, like the ones you might see in memory chips, PCI Express cards, USB cards, and many other similar desktop and mobile computing applications. Briefly, the goal of this type of statistical analysis is to compute error probabilities, eye diagrams, and related metrics given a transmission channel and particular transmitter characteristics, including noise and timing jitter. And we often use statistical analysis to design equalizers such as decision feedback or DFE filters on the receiver. We're showing this example today for several reasons. One is to demonstrate that Metlynx handles fairly sophisticated MATLAB scripts with ease. We'll be using a publicly available script called DFEI for our statistical communications analysis. Another reason is that this type of application in practice usually requires parametric analysis, such as varying the channel characteristics or equalizer topologies, and so it's a great and very natural fit for Metlynx for Spreadsheets. And finally, we'll show how to parallelize these simulations by taking advantage of the Metlynx very powerful parallel API. So let's get right to it. This is the spreadsheet that we will be working with. It lists in each row the set of parameters that we wish to analyze. In this case, a file that describes our channel and transmitter and a particular equalizer topology. For each of those parameters, we will plot the vertical bathtub, which is a probability plot as a function of the sampling threshold, and the signal-to-noise ratio. In Metlynx Studio, I have uploaded the DFEI script. I have a wrapper which calls it and extracts the signal-to-noise ratio and the data associated with the vertical bathtub, and a file which represents the properties of our transmitter and our channel. Notice, as I mentioned earlier, the DFEI is a considerably more complex and sophisticated script than the one that we looked at in our previous video. Okay, so we're ready to start the analysis using Metlynx for Spreadsheets. In the first case, we will only look at the parameters associated with one row of our spreadsheet. It takes approximately 10 seconds or so to complete this run. Again, this one represents only the first row of our spreadsheet. And here are the results. The wider are the bathtub, the more robust and the better our design. So let's now investigate the impact of the remaining sets of parameters on our system. We have 10 rows of data, 10 sets of parameters, and we'd like to see how they impact the system. Instead of waiting 10 times longer to see our results, we're going to make use of the Metlynx parallel API to get that done a lot quicker. This is the parallel version of our analysis script. Notice that it is simple, small, and virtually identical to the previous one. The main difference is the use of the function job launch, which is a part of the Metlynx parallel API, to schedule the execution of our script, in this case DFEI, in parallel. And this is all it takes to run our analysis in parallel. We'll simply specify the parallel script as the target, and we will specify the entire cell range. This analysis takes approximately 10 seconds once again to run. The only difference is small but almost fixed overhead associated with job scheduling. And just like that, we have all 10 rows processed in parallel. Thank you for your time. Today we showed you just how easy and effective it can be to run computations in parallel with the Metlynx Parallel API, all without hardware or any new software, and just with a few lines of scripting code. We hope you enjoyed the presentation. To learn more about Metlynx, please visit us at www.metlynx.com.